Hello everyone, now we are on to task 9 of the ZigZag tasks, and this is the bird. A very quite interesting one. It's fiddly. Let's have a look at it. So there's a new bird that starts created when it's instantiated, starts in a random location. At each stage it moves, it doesn't fly the bird, it just walks to a valid neighboring cell at random. We're going to lift some logic from the WorkerAnt for this. If the bird found any inside location, it eats the ants up to 5, including potentially the queen and in the nest. If they're fewer than 5, it eats all of them. That's fair enough. Displays, message when you eat some ants, and then display the bird on the methods that simulate, kind of actually print the state of the simulation. Quite a lot of changes, but all of them are quite small. There's just something fiddly around. This is really about the movement, because this is how we kind of figure out the movement of the ants as well. So let's copy this and paste it and rename it to Z8, Z9, indeed. Right, we're here. Don't need the original list, so I don't. So they want a new bird class that inherits entity. So I'm going to look for class entity and put it below, because why not? Because we just, I mean, we kind of at that level of inheritance, it makes sense to have it here rather than all the way at the bottom. So I know where to find it as well. Class bird inherits entity colon. So it's going to be a bit fiddly. Okay, we don't really need to do anything because the constructor of entity is good enough. What we need is a method to do the stuff the bird does. Now, whether that we call this advanced stage or find next, what is it, like find next, choose next cell to move to, doesn't really matter because it does both. So I'm going to call mine just move bird, and we're going to leave it at this. Self. And this is going to take the ants list, because if we need to eat the ants, we need to remove them from the list that's underscore ants in the simulation class, the instance of the simulation class, and list of neighbors. But at the moment, I'm going to do a pass, and we're going to just go and set up the bird, the beginning of the life of the bird, before we make it eat and move. So the simulation, not that far up. We don't need to be in main, really. We kind of want to be in simulation. This is how the simulation is set up. Frankly, because there's only one bird, I'm just going to put a big, old, ugly, private or protected, whatever, single underscore thing. That's going to be a new bird. And the start row is, so this is like what we have here, right? When we want to plonk a random nest in a random place, watch out because the grid is indexed from 1. So it's 1 to self number of rows, which I think this might miss the last one, but let's not think too hard about this. And another one for column that I can get from here. Cool. So we've created the bird object. We just want to also, so in the menu, which is here, right? No, it's in the main actually. When we read the choices from the menu, we have 1 and 2. It's this simulation get details and get area details. This is the thing that renders cells, like the contents of the grid. And I'm very rusty. So I just want to go looking for this method. And in this one, right, if, so this iterates over the grid basically, but it does it by row and column. Don't ask. It's a one-dimensional data structure. Lovingly over-engineered. This is the final line break. So before this, I'm not going to do an if bird, simply, well, if, so this would be self dot underscore bird. Because it's an entity, it has a in same location method that tells me if it's in the same location as another entity, like the temp cell. And if that's the case, we are going to add to details, which is the string we're building for the cell, and not even an F, right? I'm just going to bird. Cool. We have rendered the bird. We also want to get, well, get area detail is right below. Get area details. Yeah. And so same deal, right? Here it has here, and we're just going to go up. If self dot underscore bird in same location as the temp cell. I would have called it current cell being iterated over, just C, right? Whatever. If that's the case, we don't print, we add to detail plus equal bird. Cool. So that's a tick. Now, the main meat of the thing is the advanced stage. Nope, up. Control F before. Advanced stage. This advanced stage, this is where really the simulation takes the thing along. So I'm going to fit something where after we have moved the arms and done the nest advance, which is also the spawning logic, I'm going to go, no, not forbidden birds. I guess simply self._bird dot, is it move bird? Yeah, move bird, and I pass it self._ant. And let's talk about list of neighbors, right? This is choose cell to move to. I could have muted. Yeah, I really could have muted here. Choose cell to move to in the ant class. Maybe on in the workaround. Accept a list of neighbors, and all we need to know is get this. So get indices of neighbors. You pass it. Weirdly, sometimes you pass it the actual entity. Sometimes you pass it the row and column. It's slightly annoying, but you can do this easily. Same deal. We get the index of neighbor. It's going to make a list of neighbor, and this time it's not I, right? It's self._bird again, right? Like the row address of the bird and the column of the bird. Let's have a look at this particular function, because that's what uses the list of neighbors. This is like left blank at the, was it the ant level? Yeah, this is ant. But in the workaround, this is when it heads to the nest, right? And this is when it follows pheromones. But if there's no cell with a strong pheromone nearby, it does exactly this. Choose random neighbor in list of neighbors, and then passes it to the change cell. So it needs the list of neighbors. This is how I got the idea from. This is very elegant and kind of what I'd expect. So now that we know this, have I lifted the... Yeah, we need to leave the methods. Sorry, I've kind of did several takes of this video. So yeah, I'm going to need some more stuff to my bird class. Those two things, right? Like the way the WorkerAnt moves, it just does. It choose a random neighbor in the list of neighbors and get the index. That's not the actual index number, I don't think. Or maybe it is. Not super sure. Yeah, it is. Choose a random number list of neighbor and like match, and then gets that back to, I could put a breakpoint and check, I'm having a doubt now, but passes this to change cell. So I'm going to need to lift those two methods from, and they actually live in the ant class. So the bird class would really be a subclass of the ant class. Really what we need is like a moving entity class, because entities are for grid cells, but you know, it's complicated. Now, if you're an OOP purist, you could have said that we wanted to maybe either inherit the ant class as well, or compose, just kind of have our little private instance of the ant class so we can call those methods. But that would have, unfortunately, what I don't like, I first thought of this, but unfortunately this is gonna increment the next ent ID, which annoys me because there's gonna be gaps in the ent IDs. But to be fair, if ants are gonna be eaten, there's gonna be gaps in the ent IDs anyway. But, so go back to my bird, this is below. 29 something, right? Yeah, and below entity. I'm just going to do a big paste of those two helper functions, which, by the way, are, you know, actual like instance methods. They have the self on this line, but you notice the self is never used, so they don't really do anything to the object, to the encapsulated attributes. Those are just helper functions that could really, to be fair, live, you know, even at the top level, but like display or whatever. And now we can make the moveBird method. So to make the moveBird method, remember I have created it in the random location. So the first thing I want to do is eat, and then maybe I'll move. So let's eat first. For A in ants, if A, remember the is, well, actually I'm going to do self, right, is the same. They're both, this is something from the entity class, and this is really quite practical, because this, I could have done a list comprehension, or just kind of put that, you could have put that on that same line as well, but like, let's do it neat, I'm not coding down to you students, you need to code down to the marker, like really break it down. Imagine you're being marked by someone whose level of Python is GCSE, is the best way to go about it. So don't use any, if you need to sort something, you're going to have to write the bubble sort. Don't just kind of sort it. Well, maybe you can just sort it. You're not going to be asked to sort something, unless they specifically ask you to do that, in which case they say that they'll want this algorithm. Anyway, so that if I'm here, I know that the ant is in the same location as the bird, and I know that it's going to get eaten, but I can't plop it out of the ant's. In that instance, it's an argument, but it's a reference to the self underscore ants in the simulation class. And because if I start taking stuff out of the list during, whilst I'm iterating over that list, I'm getting in trouble. So let's have a variable called eaten ants that starts as the empty list. And if I detect an ant that is at the location of the bird, I will just say eaten ants, right? Append a to eaten ants. And then here I'm testing if the length of eaten ants is, it should never be larger, but like the spirit is this, right? If we reach 5, certainly that's our maximum, then we break. Whoa. Yeah, because I do it the wrong way around. Break, that breaks us out of the for loop. So we are back here. And here, I'm going to do if eaten ants. So that a list, I'm contradicting myself there, but I'm sure that markers will understand. Maybe not, right? Great. If you want to maybe be explicit, if you say, if I have the iterance is not the empty list, so if the length of iterance is not equal to 0, it's larger than 0, I guess, because we could already be larger, smaller, then we need to pop them out of ons. So ons we need to iterate over this time the eaten ants and remove each of them from the ons list. Ons.remove bracket a. And then we're going to print a little message with an f string, bird at self._row, comma, self._column 8, curly length of eaten ants. Super. And this does the eat. And now for the move, I could have done this before. For the move, we do the thing that so I have my two helper functions, and you'll notice that one returns a set of coordinates. So to change, it's such a bad naming, but this is the where you want to be, to end to. And this is something that looks like what you would pass as an argument here, which again is really not well named, but that's really so that you don't twig without wrangling the code a little bit, I'm starting to suspect. So this new cell indicator happens to be the index in where you find, in that kind of like grid thing, which is also the index in the list of neighbors that you're getting from the random list of neighbors. So to move, I'm going to say self._row, comma, I'm doing it both at the same time, ._column. Efficiency becomes equal to, and it's that one right before, self_change cell. And my first new cell indicator is going to be the return value of choose random neighbor called with the list of neighbors that I have and an argument that I hadn't used yet. This is why it's still gray. Well, it's all coming together now. Who has done this? Choose random neighbors. Where am I? Okay, and then self, the thing which I think you need the row you're changing from, _row and self_column. All right, and so we have done this, we've done this, we've done this, we've done this, we have done this, we've done that. I think that's all. Task 9. I don't know, that feels too easy. Let's see if it works. Submission number 1, display overall details. Bird is in 5.5, cool, advance it by 1 stage. The bird is in 4.4, okay. Oh, no, aha, 3.4, that's not the nest, let's hope. No, it's not. And now it's already in 4.5. Ah, yes, because this was at the previous. Oh, I should have asked for the, yeah, of course, because it's so I will see them in the same cell, and then it will tell me it has eaten them. Let's see if we can make that happen again. advanced one, display, advanced one, display. I should be, yes, okay, right, oh, okay, and one of them is going to eat 2, and one of them is going to be the queen. Now, if we had done everything, all of the tasks one after the other, this is where you can see how long you can let it run to see, because surely at some point the bird's going to eat the queen, and once the bird's eaten the queen, then like the bird's going to eat every single egg. It might take a while, but like this will statistically happen, and then you can Monte Carlo how many times it happens. Anyway, that's it for this task. I'm quite happy about this. This is because I've well rehearsed. I hope it's not too fast for you, but what's important here, right, is the logic of movement, which we got from the WorkerAnt class. So without further ado, the differential. First, we create the bird in a random place. So far, so bestial, ornithological, I suppose, avian, really. And then we print bird when we encounter the bird. So this is in same location, very super practical. And what's good is symmetrical, because I could have called temcell.InSameLocation self bird. It's a method of the entity class that takes an entity. Very, very helpful. In fact, this is how all kind of detection of being the same location are done. We never kind of iterate over an actual grid and find them in the first place and go, oh, maybe we should be doing something there. So it's tremendously inefficient, is what I'm saying. But then it's AQA code. It's not meant to be. It's pedagogical. Same deal for getter area detail. And then here, this is where the magic happens. All that needs to happen in our advanced stage of the simulation class, which, if you have been following this series for a while, you know that it's on that side, that this bad boy, am I mirrored this is because I'm shooting it and whatever. This bad boy here is where really a lot the magic happens, as it were. And once we've dealt with pheromones and ants and nests, why not have an underscore bird? We have our new just move bird method. And this takes us to our class bird. Move birds use those two thing listed from choose random neighbor. I wonder if I could add something like arm number. That's just going to slow down the bird, right? But I don't want it to be 4, because if it's 4, it's like it stays in the same cell. And like I was asked to make the bird move every tick, not make the bird choose a location like the ants do, because maybe the ants don't necessarily move every tick. They might stay in place. I'm pretty sure. We'll confirm this in the future one, I'm sure. But move birds, really, I should really have a little bit of breathing space here. First, we eat using the old list removal technique. Once we have hit 5, we break out of that loop. Then we loop on the removed ones to remove them from the main larger list that we were iterating over the first time around. And move is actually super simple, that we have the 2 methods and I plug them one into the other, which is even more compact than in the ant class from which I got this logic. We just kind of use the list of neighbors that have mandated as an argument and passed when I called move bird to choose a random neighbor, and then we pass that to change cell, to which we pass our current coordinates, and change cell will return the new place you need to be, and those became cell 4 in row column. And then the circle of life continues as ants carry food and birds eat ants. Isn't nature beautiful? Red in tooth and claw. That was it for this one. I'll see you in the next one.